Hey everyone, welcome back to the channel. Today we're diving deep into the ultimate comparison between DDR7 and DDR6 RAM. We'll cover everything from speed and efficiency to business applications and future innovations. Whether you're a gamer, a professional, or just a tech enthusiast, this video has something for you. Let's get started. Let's start with the manufacturing process, which is the foundation of any memory technology. DDR6 is built on a 5nm process, while DDR7 uses a more advanced 3nm process. 5nm DDR6 This offers a balance of performance and power efficiency, with higher transistor density compared to older nodes. 3nm DDR7 It takes this a step further, packing even more transistors into the same space. This results in higher performance. More transistors mean faster data processing. Lower power consumption, as smaller transistors require less energy. Reduced heat output with improved thermal efficiency. For example, DDR7's 3nm process allows it to achieve 25,600 megabits per second speeds while consuming 30% less power than DDR6. Let's talk numbers. DDR6 currently offers a maximum data rate of 12,800 megabits per second and a bandwidth of 51.2 gigabytes per second per module. DDR7, on the other hand, delivers a data rate of 25,600 megabits per second and a bandwidth of 102.4 gigabytes per second per module. This doubling of bandwidth is achieved through PAM4 signaling. This transmits 2 bits per clock cycle instead of 1. Wider bus architecture. The DDR7 module uses a 512-bit bus compared to DDR6's 256-bit bus. This means DDR7 can move twice as much data per clock cycle, making it ideal for data-intensive tasks like 8K video editing, AI processing, and real-time ray tracing. Power efficiency and voltage. DDR7 is not just faster, it's also more power efficient. DDR6 operates at 1.1 volts while DDR7 operates at just 0.8 volt. This 30% reduction in voltage translates to lower power consumption. DDR7 consumes 30% less power than DDR6. Reduced heat output. This is crucial for maintaining system stability, especially in high-performance setups. Longer battery life. For laptops and mobile devices, this means extended usage times. For example, a DDR7-based laptop could see a 10 to 15% increase in battery life compared to a DDR6-based one, depending on usage. Latency and prefetch algorithms. Latency is another area where DDR7 shines. DDR6 has a typical latency of 14 nanoseconds, while DDR7 reduces this to 10 nanoseconds. This 28% improvement in latency is achieved through the DDR7 uses improved prefetch algorithms by a 16N prefetch buffer compared to DDR6's 8N prefetch buffer. This allows DDR7 to fetch more data in advance, reducing wait times. DDR7 optimizes the order of memory operations to minimize delays with advanced command scheduling. For gamers, this means faster frame rates and reduced stuttering. For professionals, it means quicker rendering and smoother workflows. Error correction and reliability. DDR7 introduces enhanced error correction mechanisms compared to DDR6. While DDR6 uses ECC to detect and correct single-bit errors, DDR7 adds on-die-ECC and adaptive error correction. This means DDR7 can detect and correct multi-bit errors. Adaptively adjust error correction based on workload, reducing overhead. For data centers and mission-critical applications, this translates to higher reliability and reduced downtime. The Nvidia 5000 series GPUs have arrived, and they make full use of DDR7's impressive capabilities. With a data rate of 25,600 megabits per second and a bandwidth of 102.4 gigabytes per second, DDR7 ensures smooth gameplay even at extreme resolutions, enabling 8K gaming at 120 FPS. These GPUs deliver exceptional performance, making them a game-changer for high-end gaming experiences. DDR7's low latency and high bandwidth enable complex lighting calculations in real-time for real-time ray tracing. DDR7's efficiency supports advanced AI features like DLSS, deep learning supersampling. For example, a game running on an Nvidia 5000 GPU with DDR7 RAM could see a 20 to 30% performance boost compared to DDR6. Thermal performance. Now, let's talk about thermal performance, a critical factor for both stability and longevity. DDR6 operates at a 1.1 voltage, which, while efficient, still generates a significant amount of heat under heavy workloads. DDR7, on the other hand, operates at just 0.8 volt, resulting in lower power consumption and reduced heat output. Key thermal improvements in DDR7. Lower voltage. DDR7's 0.8 V operation reduces heat generation by 30% compared to DDR6's 1.1 volts. Improved circuit design. DDR7 uses advanced circuit designs that minimize resistive losses, further reducing heat. Better thermal dissipation. DDR7 modules feature enhanced thermal management, such as integrated heat spreaders and better airflow optimization. Real-world impact. Gaming and overclocking. DDR7's lower heat output means more stable performance even under heavy loads. For example, DDR7 could maintain peak performance at 70 degrees Celsius, whereas DDR6 might throttle at 85 degrees Celsius. Data centers. DDR7's thermal efficiency translates to lower cooling costs and reduced risk of thermal throttling, ensuring consistent performance. Laptops and mobile devices. DDR7's lower heat output is a game changer for laptops and mobile devices, allowing for slimmer designs and longer sustained performance without thermal throttling. In summary, DDR7 not only outperforms DDR6 in speed and efficiency, but also excels in thermal management, making it a more reliable and sustainable choice for all types of users. Future console design. Future gaming consoles like the PlayStation 6 and Xbox Next are expected to adopt DDR7 RAM. With DDR7's 102.4 GB per second bandwidth and 10 nanoseconds latency, these consoles will offer real-time global illumination, lifelike lighting that reacts dynamically to in-game events, advanced physics simulations, and more realistic interactions between objects. Seamless open-world streaming with no loading screens, even in massive game worlds. This means the next generation of consoles will deliver experiences that feel truly next-gen. Business and IT applications. For businesses and IT professionals, DDR7 offers several advantages. At data centers, DDR7's 30% power efficiency and enhanced error correction reduce operational costs and improve reliability. In cloud computing, DDR7's high bandwidth and low latency enable faster data processing and better scalability. In AI and machine learning, DDR7's PAM4 signaling and 16N prefetch buffer accelerate training and inference tasks. For example, a data center using DDR7 could see a 20 to 25% reduction in energy costs while improving performance. Common users and PC enthusiasts. For common users and PC enthusiasts, DDR7 means the faster boot times that meant your system will start up in seconds. User can have smoother multitasking and can run multiple applications without lag. Adds future-proofing. DDR7 ensures your system is ready for next-gen software and hardware. For example, upgrading to DDR7 could reduce your system's boot time from 20 seconds to just 10 seconds. For innovators and developers, DDR7 opens up new possibilities. Real-time rendering. DDR7's low latency and high bandwidth enable real-time rendering of complex scenes. AI-driven applications. DDR7's efficiency and performance support advanced AI models and algorithms. Next-gen software. DDR7's capabilities allow developers to create more immersive and responsive applications. For example, a developer working on a VR application could use DDR7 to reduce latency and improve immersion. The future of RAM beyond DDR7. Now, let's talk about the future of RAM. While DDR7 is already here, researchers and manufacturers are already working on next-generation memory technologies. Here's what we know so far. DDR8 and beyond. Expected launch. DDR8 is speculated to arrive around 2027 to 2028, following the typical 4 to 5 year cycle for new RAM generations. Architecture. DDR8 is expected to use PAM6 or PAM8 signaling, which could transmit 3 or 4 bits per clock cycle, respectively. This would further increase data rates and bandwidth. Speed. Early projections suggest DDR8 could achieve speeds of 51,200 megabits per second, double that of DDR7. Power efficiency. DDR8 might operate at 0.6 V, reducing power consumption by another 25% compared to DDR7. 3D stacked memory. Technology. Future RAM could adopt 3D stacking, where memory layers are stacked vertically to increase density and performance. Benefits. This would allow for higher capacities, e.g. 128 GB or 256 GB per module, and lower latency due to shorter data paths. Optical RAM. Concept. Researchers are exploring optical RAM, which uses light instead of electricity to transmit data. Potential. Optical RAM could achieve terabit per second speeds and near zero latency, revolutionizing computing as we know it. Quantum RAM. Concept. Quantum RAM leverages quantum bits, qubits, to store and process data. Potential. While still in early research stages, quantum RAM could enable unprecedented computational power for AI, cryptography, and scientific simulations. DDR7 is just the beginning. With DDR8, 3D stacked memory, optical RAM, and even quantum RAM on the horizon, the future of memory technology looks incredibly promising. Whether you're a gamer, a professional, or simply a tech enthusiast, these advancements will revolutionize our devices and unlock new possibilities we can't even imagine yet. What do you think about the future of RAM? Let me know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more tech updates. Thanks for sticking with us and watching the video to the end. I'll see you in the next video. Till then, take care and bye-bye.